Our previous topic was implementation of queue using two pointers. We have used front and rear. There are some drawbacks in that method. So we'll learn what are those drawbacks and also we'll find some solutions. So there are two type of solutions, that is resetting pointers and circular queue. So in this video we'll discuss what are the drawbacks and their solutions. How to remove those drawbacks. Let us look at drawback. Here is a queue of size 7. I have an array of size 7 and already it is filled with some elements. Rear is pointing at 6 index, that is size minus 1. So I can say that queue is full. Yes, there is no space for inserting any more element. And this is the first element, so front is pointing just before that element. Now what is the drawback? I want to insert a new element in the queue. So any queue operation already we saw. If I try to insert rear is equals to size minus 1, I get a message queue is full. I cannot insert the element. But if you see, already few elements are deleted from the queue, so these spaces are free, these are vacant. I cannot use them because the insertion is done from rear end and there is no space at rear end. This is at the front end. So these spaces we cannot utilize. So the first point is we cannot reuse the spaces of deleted element. Let me delete few more elements and show you. If I am deleting this one and this one also and this one also, so front will be pointing. Now so many elements are deleted, there is only one element in the queue. Now still I want to insert NQ. So for NQ condition is checked, rear is equals to size minus 1, that is 7 minus 1, here 6, queue is full. I cannot insert an element, though there is a lot of space free. So it means second point, every location can be used only once. I cannot reuse them. Then third one, I will delete this element also. The front will point here. So front and rear are pointing at same place. So queue is empty. Front is equals to rear, queue is empty. Can I insert any element? No, queue is full because rear is equals to size minus 1. Queue is full. Rear is at last location. Third point is a situation where queue is empty also, full also. So these are the 3 points we saw, that we cannot reuse the spaces of deleted elements. Second point, we can use each space only one time. That is a similar point only. The third thing is there may be a situation even queue is full as well as empty. Array spaces can be used only once. We want to reuse the space. How to reuse the space? First solution is resetting pointers. First solution. Solution is resetting pointers. So what I should do? At any time, if a queue is becoming empty, at any place, bring front and rear pointer at the beginning, that is reinitialize them to minus 1 so that they can again start from the beginning. So in this way we can reuse those places. Let me show you a little bit by inserting few elements. Suppose I have inserted 3 elements. So I have 3 elements. Now I want to delete 2 elements. Now after deleting 2 elements, front is here. Now I want to delete one more element. When we delete one more element, front will move to the next location and this element is gone and both front and rear are at same place. So it is empty, so queue became empty. So reset them and bring front and rear at minus 1. This is what we will do in resetting pointer. Not just at the end, anywhere in between. Whenever front and rear are becoming equal, means queue becomes empty, bring them quickly on minus 1 so that we can reuse the places. But this method doesn't guarantee that these spaces will be reused definitely. If a queue is not becoming empty at any time, then we cannot reset them. And we cannot even insert more elements. So this method doesn't guarantee reusing of spaces. Then we want second solution. So let us look at circular queue.